Hello, this is Sujit. Welcome to Physics 2020. So today in this section we are going to discuss the 10 numericals of the topic, that is dot product of vectors. So in the previous section we have discussed the concepts of dot product of vectors. What is dot product? How to multiply two vectors. What are the ways of multiplying the two vectors? That is vector multiplication with a scalar quantity, dot product of vectors, cross product of vectors. So these are the things we have discussed, and what is the resultant of multiplying two vectors in a scalar form or using dot product, and what is the result and the properties of scalar product. These are the things we have discussed in the previous class. So today in this section we are going to discuss the 10 numericals of dot product. Okay, before going to the problems, let's have a quick recap of what we have discussed in the previous section. Okay, so first dot product of vectors. So suppose two vectors, number one, two vectors, that is A vector and B vector. So A vector dot B vector is equal to, what is the formula? That is modulus of A vector, modulus of B vector and cos theta. So that's equal to, we can write AB cos theta. Okay, cos theta. Then second thing, if two vectors are perpendicular, these two vectors are perpendicular, that is A vector is perpendicular to B vector, then what is dot product? That is A vector dot B vector is equal to A vector dot B vector is equal to 0. Suppose the two vectors are parallel, that is A vector is parallel to B vector, then the dot product, that is A vector dot B vector is equal to AB. Okay, AB. Then the fourth thing, that is if the two vectors are, what is the angle between the two vectors? If theta is the angle between the two vectors, that is the cosine of the angle theta between the two vectors can be found, which using the formula, that is cos theta is equal to A vector dot B vector divided by modulus of A vector modulus of B vector. So this is the formula to find the angle between the two vectors. If the two vectors are represented in a rectangular component form, okay, rectangular component form, we can write, suppose A vector is equal to, that is Ax I cap plus Ay j cap and Az plus Az k cap, and similarly B vector is equal to Bx I cap plus By j cap plus Bz k cap. So we can write, that is A vector dot B vector is equal to, what is the formula? Ax Bx plus Ay By plus Az Bz. This is the formula. Okay. So what is the angle between the two vectors? That is cos theta is equal to, if the vectors are given in the rectangular component form, so what is the angle between the two vectors? We can write, that is cos theta is equal to A vector dot B vector, that is Ax Bx plus Ay By plus Az Bz divided by square root of modulus of A vector. So square root of Ax square plus Ay square plus Az square into square root of what is modulus of B vector? That is Bx square plus By square plus Bz square. Okay, Bz square, that is the formula. Okay. Then what is the formula for work done? So work done is equal to force into F vector dot displacement vector. Okay, So that is equal to work done is a scalar quantity, force is a vector quantity, and S is a scalar quantity. Okay, sorry, vector quantity. Then what is the formula for instantaneous power? Power is equal to F vector dot velocity vector. So these are the formula you have to keep in mind before solving the problems. Okay. Okay. So first question. So find the angle between the vectors. Find the angle between the vectors. A vector is equal to I cap plus 2j cap minus k cap, and B vector is equal to minus I cap plus j cap minus 2k cap. So two vectors are given, A vector and B vector, so in a rectangular component form. So we have to find the angle between the vectors. So solution so the cosine of the angle between the two vectors, we know the formula, that is cos theta is equal to A vector dot B vector divided by modulus of A vector modulus of B vector. Okay. So A vector dot B vector is equal to, what is A vector? I cap plus 2j cap minus k cap dot, what is B vector? Minus I cap plus j cap minus 2k cap. So that's equal to, so the coefficient of I vector, that is I cap, 1 into 1, so minus here, so 1 into minus 1, so minus 1, I cap dot I cap 1, so then plus 2 into 1, okay, here coefficient is 1, so 2 into 1, that is 2, j cap dot j cap 1, so 2, minus into minus plus 2 into 1, 2, k cap dot k cap is equal to 1, so that's equal to 4 minus 1, okay, 4 minus 1, so we will get 3. So this is A vector dot B vector. Okay, then modulus of A vector. Modulus of A vector is equal to square root of coefficient 1 square plus coefficient 2 square plus coefficient, so minus 1 square, okay, that is 1 square. So A vector is equal to square root of 1 square 1 plus 2 square 4 minus 1 the whole square, that is 1. So we will get root of 6. Modulus of B vector is equal to square root of minus 1 square 1 plus 1 square 1 plus minus 2 the whole square 2. So we will get root 6. Okay, root 6. So apply the formula, that is cos theta is equal to A vector dot B vector, that is 3, divided by modulus of A vector root 6 into modulus of B vector, that is root 6. So that's equal to 3 divided by root 6 into root 6, that is 6. Okay, so that's equal to, so 1 3, that is 1 by 2. So cos theta is equal to 1 by 2. So theta is equal to cos inverse of 1 by 2. Okay, cos inverse of 1 by 2. So which angle? That is, we will get 1 by 2, that is cos 60. Okay, 60. So therefore theta is equal to 60 degree. Okay, 60 degree. Cos 60 is equal to 1 by 2. Okay. So what is the answer between? So find the angle between the vectors. Okay. So the angle between the two vectors is 60 degree. Clear? So prove that, question 2, second question, prove that the vectors A vector is equal to I cap plus 2j cap plus 3 cap and B vector is equal to 2I cap minus j cap are perpendicular. So if we get the dot product as 0, so if two vectors are perpendicular means the angle between the two vectors is 90 degree. So cos 90 is equal to 0. Okay. If two vectors, that is if the dot product is equal to 0 means we can say that two vectors are perpendicular. Okay, perpendicular. So solution. So A vector is equal to I cap plus 2j cap plus 3k cap. B vector is equal to 2I cap minus j cap plus 0k cap. Okay, 0k cap. So A vector dot B vector is equal to I cap plus 2j cap plus 3k cap dot 2I cap minus j cap plus 0k cap. So that's equal to 1 into 2, that is 2. Okay, 2 into 1, so here minus 1, so 2 into minus 1, so minus 2. Then 0 into 3, that is 0. So that's equal to 2 minus 2, 0. So we will get A cap dot B cap, that is the dot product of two vectors is equal to 0. If the dot product of two vectors is equal to 0 means the two vectors are perpendicular. Why? Because A vector dot B vector dot B vector is equal to modulus of A vector modulus of B vector into cos theta. Okay, cos theta. If theta is equal to 90 degree, that we can write, that is AB cos theta. So if theta is the angle, if theta is equal to 90 degree, that is pi by 2. So cos 90, so that's equal to AB cos 90. So we will get, what is cos 90? Cos 90 is 0, so we will get 0. So A vector dot B vector is equal to 0. If the dot product is equal to 0 means we can say that A vector perpendicular to B vector. Okay? Find the value of lambda. Find the value of, question 3. Find the value of lambda such that the two vectors A vector is equal to 2I cap plus lambda j cap plus k cap and B vector is equal to 4I cap minus 2j cap minus 2k cap are perpendicular to each other. So This question, these two vectors are given. So the A vector and B vector is given. They are perpendicular to each other. So if these two vectors are perpendicular, we have to find the value of this lambda. Okay. If these two vectors are perpendicular means we can write. So in the question it is given, these two vectors are perpendicular. We can write that is A vector dot B vector is equal to 0. Okay. So 2 cap plus lambda j cap plus k cap dot, what is B vector? 4 cap minus 2 j cap minus 2 k cap is equal to 0. So 2 into 4, that is 8. I into I that is 1 plus minus 2, okay, minus 2 into lambda minus 2 lambda j dot j 1 minus, okay, minus 2 into 1, that is 2 is equal to 0. So minus 2 lambda plus 8 minus 2, that is 6 equal to 0, minus 2 lambda is equal to minus 6, minus minus cancel, lambda is equal to 6 by 2, so that is equal to 3. So the value of lambda is equal to 3. Lambda is equal to 3. Clear? So find the value of lambda such that the two vectors, A vector is equal to 2 cap plus lambda j cap plus k cap, and B vector is equal to 4 cap minus 2 j cap minus 2 k are perpendicular to each other. So in the question it is given these two vectors are perpendicular. Perpendicular means immediately we can write the dot product is equal to 0. So find the dot product lambda, from that you can find the value of lambda. Okay, lambda is equal to 3. Clear? So fourth question, a body is constrained to move along the z axis, okay. A force F vector is equal to minus I cap plus 2 j cap plus 3 k cap is acting on the body. Okay, so where I, j and k are the unit vectors along the x, y and z axis. So find the work done. In displacing the body 4 meter, along the z axis. This is a question. So a body is constant to move along z axis only. Okay, so a force is acting on the body, that is force is given in a rectangular component form, minus I cap plus 2 j cap plus 3 k cap is acting on the body. So find the work done in displacing the body 4 meter along the z axis. So F vector is given. So F vector is equal to minus I cap plus 2 j cap plus 3 cap. So what is the displacement vector? Displacement vector is along the z axis only. Z axis only means, so the other two components, x component and y component is 0. That is the meaning. Okay, so the displacement vector we can write S vector is equal to 0 I cap plus 0 j cap plus, what is the value of in the z axis? That is 4 meters. That is 4 k cap. Understood? So that's why a body is constrained to move along the z axis only. So the body is moving in the z axis alone means other two components are 0. So the displacement vector in the rectangular component form we can write, that is s vector is equal to 0 I cap 0 j cap plus 4 k cap. Easy. Then we have to find the work done. So work done is equal to, what is the formula? F vector dot displacement vector. So that's equal to F vector minus I cap plus 2 j cap plus 3 k cap. So dot, what is S vector? That is 0 I cap plus 0 j cap plus 4 k cap. So that's equal to, so 0, 2 into 0, 0. Okay, so that's equal to 3 into 4, that is 12. So 12 k into k. So 12 work done, what is the unit? That is joule. 12 joule is the answer. Clear? Fifth question. If modulus of A vector plus B vector is equal to modulus of A vector minus B vector. Okay, B vector. So find the angle between the, angle between A vector and B vector. So one condition is given, that is modulus of A vector plus B vector is equal to modulus of A vector minus B vector. So we have to find the angle between the two vectors, A vector and B vector we have to find. Okay. So solution, modulus of A vector plus B vector is equal to modulus of A vector minus B vector. Okay, so squaring on both sides. So modulus of A vector plus B vector square is equal to modulus of A vector minus B vector. Okay, B vector square. So that we can write modulus of A vector square is equal to A vector dot A vector. So we have studied on formula this, that is modulus of A vector square is equal to A vector dot A vector. Modulus of A vector square is equal to, we can write that is A vector dot A vector. So how we are writing this, that is modulus of A vector square is equal to A vector dot A vector. That is A vector, actual result is modulus of A vector square is equal to A square. Okay, A square. So A vector dot A vector, what is the answer? So that's equal to modulus of A vector, modulus of again A vector, then cos 0. So the dot product of a vector with itself. Okay, with itself. So cos 0. Okay, cos 0. The angle between the two vectors A and A, that is 0. Okay. So here one vector, this is A vector. Okay, A vector. So again we are taking the dot product of A vector. So the same vector. Though what is the angle between A vector and A vector? That is 0 only. Okay. So cos 0. So we will get, that is what is mod A, that is A dot. What is mod A? Cos 0 1. So we will get that is A square. Okay, A square. So here modulus of A vector, that is also A square. Modulus of that is A vector dot A vector, also we will get A square. So therefore we can write that is modulus of A vector square is equal to A vector dot A vector. Modulus of A vector square is equal to, we can write A vector dot A vector. Clear? So by using this result here, okay. So we can write that is A vector plus B vector dot A vector plus B vector is equal to A vector minus B vector dot A vector minus B vector. Clear? So take the dot product, A vector dot A vector plus A vector dot B vector plus, okay, then B vector dot A vector, so that we can write that is A vector dot B vector. A vector dot B vector is equal to, we can write B vector dot A vector because dot product is commutative, okay, commutative. So A vector dot B vector plus, okay, plus B vector, then B vector dot B vector is equal to A vector dot A vector minus A vector dot B vector minus B vector dot A vector, that is A vector dot B vector, minus into minus plus B vector dot B vector. Okay, so A vector dot A vector, that is A square plus A vector dot B vector. So here A vector dot A vector, A vector dot A vector, that is 2 times of A vector dot B vector plus B vector dot B vector, that is B square, is equal to A vector dot A vector, A square, minus A vector dot B vector, A vector dot B vector, that is 2 times of A vector dot B vector plus B vector dot B vector, that is B square. So this A square cancel, B square cancel, okay. So bring this to AB this side. So we will get 2 A vector dot B vector, A vector dot B vector plus 2 A vector dot B vector is equal to 0, okay, 0. So 2 A vector dot B vector plus 2 A vector B, that is 4 A vector dot B vector is equal to 0, okay. So therefore A vector dot B vector is equal to 0. So we are getting A vector dot B vector is equal to 0. What we have to find? Find the angle between A vector and B vector. If the dot product A vector dot B vector is equal to 0 means, immediately we can write A vector is perpendicular to B vector. So A vector is perpendicular to B vector, or the angle between the vectors, that is theta is equal to pi by 2. Theta is equal to pi by 2. Clear? So sixth question. Find the angle. Find the angle of the vector. Find the angle of the vector. A vector is equal to I cap plus j cap with the x-axis, okay, with the x-axis. So a vector is given, so A vector is equal to I cap plus j cap. Okay, vector is given in rectangular component form with the 2 axes, okay, 2 axes. So A vector is equal to I vector plus j cap, I cap plus j cap. So we have to find the angle of this vector with the x-axis. Okay, x-axis. So what is the vector form of x-axis? So b vector is equal to the vector form of x-axis, that is only unit vector. Okay, that is I cap plus 0 j cap. X-axis, y-axis. Suppose a vector is like this, a vector. Okay, both x component and y component. So with the x-axis, x-axis means this one. Okay, so I cap. So in x-axis, y component is 0. So what is the vector form of x-axis? B vector is equal to I cap plus 0 j cap. Okay, so B vector. So we have to find the angle between these two vectors. So cos theta is equal to a vector dot b vector divided by modulus of a vector modulus of b vector. Okay, so that's equal to a vector dot b vector. So 1 into 1, 1 plus 1 into 0, that is 0, divided by modulus of a vector, that is root of 1 square plus 1 square, that is 2, into modulus of 1 square, that is 1. So that's equal to 1 divided by root 2. Okay, 1 divided by root 2. Clear? So cos theta. So theta is equal to cos inverse of 1 by root 2. Okay, so theta is equal to what is the value? That is theta is equal to cos 45. Okay, cos 45 value, that is 1 by root 2. So the angle between these two vectors is theta is equal to 45 degree. Clear? So the next question. Seventh question. If a vector dot b vector is equal to minus of modulus of a vector modulus of b vector. Okay, b vector. Then a vector and b vector are option A perpendicular to each other. Perpendicular to each other. B, they act in the same direction. They act in the same direction. Option C, they act in the opposite direction. They act in the opposite direction. They act in the opposite direction. Option D, they act in any direction. They act in any direction. So what is given in the question? A vector is equal, a vector dot b vector is equal to minus of mod a vector b vector. Then a vector, then a vector and b vector are. So 4 options are given, perpendicular to each other, they act in the same direction, they act in the opposite direction, they act in any direction. So a cap dot b cap is equal to minus of modulus of a vector modulus of b vector. So what is my a vector dot b vector? Modulus of a vector modulus of b vector, then cos theta. Okay, cos theta is equal to minus of mod a vector mod b vector. Okay, b vector. So a cap mod a vector mod b vector cancel. So cos theta is equal to minus 1. Then theta is equal to 180 degree. Theta is equal to 180 degree. So 180 degree means one vector is acting in this direction. So another vector is acting in the another direction. So A vector in this direction and B vector in this direction. So the angle between these two vectors, okay, that is 180 degree. So they act in the opposite direction. So option C is correct. Okay, they act in the opposite direction. Clear the question? Clear? A particle is moved in the xy plane with a constant force. Okay, the linear momentum of the particle, okay, linear momentum of the particle is given by P vector is equal to 2 cos t into I cap plus 2 sin t into j cap. Okay, j cap. So find the angle between P vector and F vector. So this is the question. Okay, a particle is moved in a xy plane. Okay, xy plane with a constant force. So the linear momentum of the particle at any time, at a time t, okay, at a time t is given by P vector is equal to 2 cos t I cap plus 2 sin t j cap. So find the angle between P vector and F vector. So solution, P vector, that is the momentum vector. Okay, momentum vector is equal to 2 cos t I cap plus 2 sin t j cap. Okay, j cap. So according to Newton's second law, okay, Newton's second law, the rate of change of momentum is force. Okay, so F vector is equal to, we can write dP vector divided by dt. So that's equal to d by dt of what is P vector, that is 2 cos t I cap plus 2 sin t j cap. So that's equal to, so differentiation of cos t minus sin t, so minus 2 sin t, okay, minus 2 sin t I cap plus 2 differentiation of sin t cos t, so cos t j cap. So this is F vector. Okay, F vector. So what is the modulus of P vector is equal to square root of 4 cos square t plus 4 sin square t. So the coefficient of I vector, that is 2 cos t. Okay, so 4 cos square t, 2, that is 4 sin square t. So that's equal to, you can take 4 commonly outside, cos square t plus sin square t 1. So square root of 4, so we will get 2. Okay. So coefficient of F vector is equal to square root of minus 2 the whole square, that is 4 sin square t plus 4 cos square t. Cos square t. So that's equal to sin square t plus cos square t. This case also you can take 4 commonly outside. Sin square t plus cos square t 1, that is 4 square root of 4, that's equal to 2. Okay, 2. Okay. F vector dot p vector. Or p vector dot f vector. Okay, p vector dot f vector. What is p vector? That is 2 cos t I cap plus 2 sin t j cap dot. What is f vector? Minus 2 sin t I cap plus 2 cos t j cap. Okay, j cap. So that's equal to 2 into 2, 4. So minus 4. Okay, minus 4 sin t cos t plus 2 into 2, 4 sin t cos t. Okay, sin t cos t. So minus 4 sin t cos t and plus 4 sin t cos t is equal to 0. So therefore p vector dot f vector is equal to 0. P vector dot f vector is equal to 0. So what is p vector dot f vector? That is modulus of p vector modulus of f vector cos theta is equal to cos theta. Okay, cos theta, that is equal to 0. So here modulus of p not equal to 0, because modulus of p we have the value, that is 2. Modulus of f not equal to 0, because modulus of f is equal to 2. So here modulus of p not equal to 0, modulus of f not is equal to 0. Therefore cos theta is equal to 0. Cos theta is equal to 0. So theta is equal to that is 90 degree. Okay, theta is equal to 90 degree. Cos theta is equal to 0 means cos 90 is equal to 0. So therefore theta is equal to 90 degree. So what we have to find, that is find the angle between p vector and f vector. So here theta is the angle between p vector and f vector. Okay, in dot product p vector dot f vector is equal to modulus of p modulus of f cosine of the angle between the two vectors. So theta is equal to 90 degree means we can conclude that is p vector is perpendicular to f vector. Okay, p vector is perpendicular to f vector, or p vector is orthogonal to f vector. Clear? So in the question, that is momentum is given, momentum. So the particle is moving with a constant force f. So F is equal to, according to Newton's second law, the rate of change of momentum is equal to force. So using that principle, we are finding the force. F vector is equal to dp vector divided by dt. So differentiating the momentum vector with respect to t. So we will get the force. Okay, force. So modulus of p vector we have to find out. So we will get 2 modulus of f vector, that is equal to 2. Then find the p vector dot f vector. Okay, p vector dot f vector. So we get the answer, that is 0. So p vector dot f vector, we can write modulus of p vector modulus of f vector cos theta is equal to 0. So this much equal to 0 means, so already we found that modulus of p not equal to 0, modulus of f not equal to 0. Okay, 0. So therefore cos theta is equal to 0. So cos theta is equal to 0 means theta is equal to 90 degree. Clear? A vector, B vector and C vector are unit vectors. Okay, unit vectors. If A vector plus B vector plus C vector is equal to 0, then A vector dot B vector plus B vector dot C vector plus C vector dot A vector. Okay, C vector dot A vector is equal to option A 1, option B minus 3 by 2, option C minus 1 by 2, option D 0. Okay. So in the question it is given A vector, B vector and C vector are vectors of unit magnitude. Okay, unit magnitude. So one condition is given, A vector plus B vector plus C vector is equal to 0. Then we have to find A vector dot B vector plus B vector dot C vector plus C vector dot E vector is equal to, 4 options are given, 1 minus 3 by 2 minus 1 by 2 D 0. Okay. So first we have to find, that is A vector dot A vector plus B vector plus C vector. So taking the dot product A vector with A vector plus B vector plus C vector. So in the question it is given A vector plus B vector plus C vector is equal to 0. So any vector taking the dot product with the null vector is equal to, we get 0. Okay, 0 only. So therefore we can write this equal to 0. Okay. So in the left hand side, multiply that A vector dot A vector. So already we find that, studied that. That is a vector taking the dot product with itself. That is A vector dot A vector is equal to A square. Okay, A square. So A vector dot A vector we can directly write, that is A square plus A vector dot B vector A vector dot B vector plus A vector dot C vector is equal to 0. So this, what is A square? That is, this is the magnitude only. Okay, A vector is equal to magnitude. So in the question is given, that is A vector, B vector and C vector are vectors of unit magnitude. So A square is equal to 1. Okay, 1. So therefore A vector dot B vector plus A vector dot C vector is equal to minus 1. So this one comes this side, so minus 1. So take it as equation number 1. Okay. Then so B vector dot A vector plus B vector plus C vector is equal to 0. So B vector dot A vector, B vector dot A vector, we can write A vector dot B vector. B vector dot A vector we can write A vector dot B vector, because dot product is commutative. Okay. So A vector dot B vector plus B vector dot B vector, B square plus B vector dot C vector. Okay, B vector dot C vector is equal to 0. So this is 1. So 1 comes that side, minus 1. So we can write A vector dot B vector plus B vector dot C vector is equal to minus 1. Take it as equation number 2. Okay. Then C vector dot A vector plus B vector plus C vector is equal to 0. Is equal to 0. So C vector dot A vector we can write that is A vector dot C vector plus B vector dot C vector. C vector dot B vector, so we can write B vector dot C vector plus C square is equal to 0. Okay, C square is equal to 0. So we can write that is A vector dot C vector plus B vector dot C vector is equal to minus 1. Take it as equation number 3. So 1 plus 2 plus 3 implies, okay, 1 plus 2 plus 3. So we can write A vector dot B vector plus A vector dot C vector plus second equation A vector dot B vector plus B vector dot C vector plus A vector dot C vector plus B vector dot C vector is equal to minus 1 minus 1 minus 1, that's equal to minus 3 minus. So A vector dot B vector, A vector dot B vector 2 times, A vector dot C vector, A vector dot C vector 2 times, B vector dot C vector, B vector dot C vector 2 times. So 2 times of A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equal to minus 3. So therefore A vector dot B vector plus B vector dot C vector plus C vector dot A vector is equal to minus 3. This 2 comes this side, so minus 3 by 2. So listen to the question. So we have to prove A vector dot B vector, A vector dot B vector, B vector dot C vector, B vector dot C vector plus C vector dot A vector is equal to. So the options, my option B is minus 3 by 2. So this is the answer, minus 3 by 2. So clear? So 10th question. Consider a cube. Consider a cube of edge length A. Okay. Edge length A. So this is x-axis, y-axis, z-axis. So this is the origin A, B, C, D, E, F, G, okay, G. Okay, so what is the angle between OC vector and OD vector? OC vector and OD vector. So options A cos inverse of 1 by 2. Option B cos inverse of 1 by 3. Option C cos inverse of root 3 divided by 4. Option D cos inverse of root 2 divided by 3. So a cube is given of the edge length, okay, each and all the edges, that is length is A. So we have to find the angle between OC vector. So OC vector and OD vector we have to find. So first we have to fix the coordinates of A. So the point C is just like the point at the space, okay, point at the space. It occupies all the three axes, that is x axis, y axis and z axis. So all the edges, okay, all the edges is of same length, that is A only, okay, A only. So the coordinates of C we can write, that is C of A comma B comma, A comma A. What is the coordinate of D? The coordinates of D. So the D is at XZ plane, okay, XZ plane. So XZ plane means the Y coordinate is 0, okay, Y coordinate 0. So D of A comma 0 comma. So this is the coordinates of the points C and D, okay, D. So in vector form how we can write, that is OC vector. OC vector is equal to AI cap plus AJ cap plus A K cap. Okay. So the OD vector is equal to AI cap plus 0 J cap plus A K cap. So we have to find the angle between the two vectors, okay, vectors. Okay, cos theta is equal to, what is the formula? Cos theta is equal to OC vector dot OD vector divided by modulus of OC vector modulus of OD vector. Modulus of OD vector. Am I right? So that's equal to OC vector dot OD vector. A dot A, that is A square, plus A into 0 0. A dot A, that is A square, divided by, what is modulus of OC vector? That is root of A square plus A square plus A square, that is 3A square. Modulus of OD vector, that is 2A square. So that's equal to A square plus A square, 2A square, divided by root 3A square we will get, that is root 3A, okay, root 3A, into root 2A square, that is root 2A, okay, root 2A. So this A square, this A square cancel. So that's equal to this 2 we can write, that is root 2 the whole square, okay, root 2 the whole square, divided by root 3. Okay, root 3 into root 2. This root 2 cancel. So we will get that is a root of, that's equal to root of 2 by 3. Okay, 2 by 3. This is cos theta. Cos theta. Okay. So therefore theta is equal to cos inverse of root 2 by 3. Cos inverse of just a second answer. So this option, that is cos inverse of root 2 by 3. Okay, root 2 by 3 within the root. Okay, within the root. So theta is equal to cos inverse of root 2 by 3. Okay, this is the answer. So option D is the answer, that is cos inverse of root of 2 by 3. Okay, root of 2 by 3. So clear? So this is the answer. So with this I wind up this session. So in the dot product of vectors we have solved, that is 10 problems. Okay, 10 problems. So in the next session we will discuss the concepts of, that is cross product of vectors or vector product of vectors. Stay tuned. Bye.